All right, guys. So welcome to Biology 105 Lab. This will have live class on Wednesdays at 9 a.m. But if you can't make it to the live classes, that's okay. I will record all of these sessions and I'll post the link to Canvas later tonight. So every Wednesday night, look for the recording of the lab for that day. But if you want to come to lab, you're free to. I will be here on Wednesdays at 9 a.m. Explaining the lab. So today we're just going to go through kind of what lab will look like this semester. I'll take you through the syllabus and we'll try to answer all your questions. I also hold office hours. So if you guys are looking at my screen, I have your opening kind of homepage up in Canvas for the Bio 105 lab. My welcome video is there. There's an introduce yourself discussion that just allows me to get to know you and why you're taking this course. Some of you might be taking it for pre-nursing to go on to take anatomy, and others of you might just be taking it as a general science course. And I just like to know that, to know kind of who the students are. The syllabus is here, which we'll go over. You do have a syllabus quiz that's due by this Sunday. So you'll notice all of your assignments are due by Sunday at midnight. So just keep that in mind. Everything's due by Sunday at midnight. I always keep that the same. So your syllabus quiz, you can use your notes, unlimited attempts, and the Proctorio practice quiz are both due by Sunday at midnight. And there's information on how to use Proctorio. So what Proctorio is Proctorio is kind of an artificial intelligence system that's going to watch you guys take quizzes and exams. It doesn't use that information for anything. And it doesn't use your information. All it does is it kind of makes sure that your face is always in the screen. It will lock your screen so you can't, use a window to look for help for anything. So this is not quite what I wanted. So here's some information on how to download Proctorio. So you just need to download the extension. It doesn't take up much space, and you should use it doing Google Chrome. No personal information is required. You don't need to provide any other information. You just need a webcam when you take the quizzes and exams. I don't even look at your recordings unless Proctorio flags you for something. So it doesn't save your recordings. It doesn't, I probably won't even look at your recordings. Yes, the Proctorio quiz can be taken many times. Yes, Yvonne, and I will keep the highest score or the highest attempt. And the Proctorio quiz, when you take it, you'll see is very easy. It's only worth 2 points. I think it's 2 questions. But yeah, you can take it as many times as you want to keep practicing to make sure it works. One thing to note, and I cannot stress this enough, that when we're taking quizzes or exams, if it is asking you for an access code, that just means that Proctorio is blocked on your computer for some reason. So when you take in, as you're taking quizzes this semester and the final lab exam, it should just open for you. It should never ask you for an access code as long as Proctorio, the extension, is downloaded correctly. So make sure you download the extension for Proctorio, and those directions are shown here. And then you can practice doing Proctorio with a practice quiz. So those 2 quizzes are just due by Sunday. But again, they're they're low stakes. You don't have to worry about them. You can use notes for them. It's just for you to practice using Proctorio. And then the syllabus quiz is just to make sure we're all on the same page with the syllabus. Here's the class Zoom link for Wednesdays at 9 a.m. And you guys all made it here. So I'm not worried about you guys, but for those of you who are watching the recording, this is what you can click on to come to class on Wednesdays at 9 a.m. But again, these classes are not mandatory. I will record them. And after this recording, I will probably add in another link here to the YouTube channel that will include recordings for this lab class. That YouTube channel link is unlisted. And what that means is you can only access it if you have the link. So only our group of students can access it. So it's not in the public domain. We'll go through the syllabus, but so I'm always going to keep this getting started module at the top for all the important information. And then below that, I'll have modules for each lab or each week. So this first lab that we have is the scientific method and the metric system. There's a lab guide, which is what we're going to go over in a little bit together, and then a worksheet. And the worksheet should be a Word document. And I will pull that up here. So the worksheet, you can download it, and then it'll pull up a Word document that you can either print out and write in your answers. and then scan them or take pictures of them. It might be easier to actually just type in your answers. It'll be a Word document. If you have Microsoft Word on your computer, you guys should be able to get Microsoft Word, I believe, with your school email addresses as well. But this Word document you can type in, and then once you finish typing in the lab information, and you shouldn't need any materials for lab. So we provide you with all the materials, the worksheet, some of the lab guides will tell you how to do some of the experiments, but you shouldn't need necessarily any materials. We'll provide you with pictures of some of the experiments you might need to look at. But this is the first worksheet. It's 12 pages, but that's because a lot of these pages have just a lot of information in them, background information on the metric system, on the scientific method. So it seems like a lot of pages, but it just has a lot of information. This worksheet will have activities, and then it'll say, see the lab guide. And the lab guide is also I provide you with. So under each module, there's the lab guide and here's the worksheet, and you can kind of keep both open at the same time to use the lab guide as you're filling out the worksheet. So this lab material that you'll get for the week, so this again, lab 1 is due by Sunday, the worksheet. This lab material I will always post by Monday. So realistically, you could probably do these worksheets without ever coming to live class or ever watching the recording of live lab. It would probably be helpful to still come to live class or watch the recording, but if you want to get a start on it on Monday, you can always take a look at it before it's due. So I was just going to get to that, Jose. So here's submitting the Lab One worksheet, and it's a file upload. So what you'll do is you'll submit a file upload. And to try to encourage group work, which I know might be really difficult for some of you, especially in an online setting, and for some of you who might be working or have a lot of stuff going on, you can always submit it individually if you would like. But what I've created are lab groups. And if you go over to people, and then I'm not sure how it'll look like for you, but if you click on the Bio 105 lab groups, you'll see people have already started to form groups. You can join a lab group. There's pros and cons to joining a lab group. The pros is that you'll have other people to work with. So you can exchange email addresses. You can set up your own Zoom. If you want during live class, you can come to my Zoom live class or my Zoom office hours, and I can put your group in a breakout room to work on the lab. Or you can set up a Google Meet or however else you want to kind of meet together virtually to work on the group, the lab. So Jose, to answer your question, I'm going to make this non-mandatory as well. I would encourage you to form a lab group, because if you do this, it'll be less work for you. As long as everyone participates, you only need to submit a lab assignment for each lab. So depending on if that's good or bad for you, I'm going to let you guys decide that, if that makes sense, Jose, to answer your question. So you feel free to join the lab group. You can complete it as a group, or some of you could do one activity, others can do the other activity. You're still all responsible for knowing the information, but I'm kind of going to leave that up to you. If you want to do the lab worksheet individually and still submit it by yourself, you'll just get your own grade. And yes, Kathy, if one person turns it in for your group, you guys will all get the same grade for it, as long as all of your names are on it. And if someone does not participate, then just don't put their name on it, and I can help alleviate. I know there's sometimes stressful situations when working in a group, and I can help with that. But I would say, I'm going to leave it up to you guys. If you want to work in a group, I give you an option to form a lab group here under people, so you can join a group. If you don't want to do that and just want to work individually, that's okay too. Does that sound good to everyone? Can I get a thumbs up? There should be a reaction button on the bottom. Maybe you can give me a happy face or a thumbs up. And good. Okay. All right. So that is good. And we're kind of already going through the syllabus as I'm talking you through this. But we'll get to the syllabus and I'll reiterate everything. And then what I also have here, so a part of each lab module, you'll have the worksheet that's due that you'll submit as a file, and then you'll have a lab quiz. On my end, I can see it, but I haven't published it yet. But the lab quiz will always be due the following week. So in your mind, if you think about, so this week on Sunday night, you have the Lab One worksheet to do and the Proctorio practice quiz and the syllabus quiz due. The following week, you'll have the Lab 2 worksheet due on a Sunday night, which will be September 5th. And then you'll have this Lab 1 quiz due. So each week you'll have the worksheet for that lab week due, as well as the quiz to take on the previous week's lab. So you'll kind of have a quiz and a worksheet due every week, except the quiz will be for the last week's lab, if that makes sense. Those are your grades for the semester, and the only other grade that you're getting, and don't go over the syllabus now, is just the final lab exam, which will be cumulative over all of the labs. So let's take a look at the syllabus. And as I'm talking, please feel free to ask me any questions. So here's our syllabus. I have 2 Biology 105 sections. All the course material will be delivered using Canvas, so synchronously in live class at 9 a.m. on Wednesdays, but I also will record this. I'll provide you with a link to our class YouTube channel. It's a private link that only you guys have access to, so you can always watch the recordings on Wednesday night. Here are my Zoom office hours. Thursdays, I've changed this. Now my office hours are Thursdays at 11:30. So this is mistaken, but under the modules, the date and hour time is correct. Office hours, I have several classes that are using that office hours. So if you do need to set up another time to meet with me, feel free to let me know. Here's the course description. All students are welcome. We'll treat each other with respect. I'm here to help you guys. I know we're virtual, but I will do whatever I can to help you in this virtual environment. So just please speak up and let me know if you need help. You're also probably going to hear from me. If you don't complete assignments, you'll probably hear from me. Learning outcomes, this is what you'll get out of this course by the time you finish it. And if you guys are going on to nursing and will take anatomy after this course is really helpful for that. This is, I think, the only college I teach at that requires this course. It's kind of a prerequisite for anatomy. And I know it really helps students do better in anatomy. So the course materials, you just need access to Canvas, and then you need a computer with a webcam, because again, we'll be using Proctorio, which you need to download the extension for, and those instructions are shown in that first module. And this is just a proctored testing application. It will watch you, it will record your screen, but it doesn't save your information. It doesn't save the recordings. I never look at these recordings. I use Proctorio for all my classes, and I only look at them if Proctorio flags you. So if you get up to leave to use the restroom, your screens will be locked. So you won't be able to use your screens, but you will have access to a calculator and like a note-taking place. But if you turn your head away or are looking down or looking just any way other than your screen, it will also flag you. But otherwise, I won't look. Course materials, these have been made by our full-time faculty member, Melanie Fierro, and she's been awesome. This lab and this course has been made by her, and she's very organized. So thanks to her, she just doesn't want us to share any of her materials. Here are some important course dates. You guys get a separate grade for lecture and a separate grade for lab. For lab, as long as you do your lab worksheets, and a lot of your lab worksheets, I will grade for completion, meaning that if you submit something and you try to answer all the questions, even if a couple are wrong, I will most likely give you full points just for completing the lab. The lab quizzes, you'll be graded out of 10 points for how many questions you get right, and then the final lab exam as well. But if you guys show up to class and submit your assignments, your worksheets, I promise you this will go really smoothly for you. It will be very easy to pass this lab course. Grades within 0.5% will consider to be rounded. So for example, if you have an 89.5%, I will most likely round that up to a 90%, which would be an A. No grades are dropped. So I don't drop any grades. I don't offer any extra credit or makeup assignments, but if you do have an emergency situation, let me know. But at the end of the semester, I don't offer any extensions or emergencies or extra credit or anything like that. I don't offer any extra credit, mainly because for what I just told you about the lab assignments, a lot of your lab worksheets, as long as you put in effort to try to do them, and you get most of the questions right, or I can tell you're understanding the concept, but it might be a little off, I give you full credit for that. I won't assign any incomplete grades. And here's your assigned work. So there's a syllabus quiz and a Proctorio practice quiz, each worth 10 points. The bulk of your points are coming from lab activities, which are 10 points each. Your lab quizzes are, 20 points each. This is kind of subject to change because depending on what the lab activity is for that week, I most likely will have a quiz for most of your labs. And there's 18 of them. So this might be a little bit more, and I might drop down the point value for each then to try to keep it around only 200 points for lab quizzes. And then you have a cumulative lab final, which means it'll be based on all previous labs. And again, quizzes and your lab final will be using this Proctorio testing system here. So out of 500 points, this is how many you need to get an A, a B, a C, a D, and an F. And that's on a 90, 80, 70, 60% scale as well. Class meetings come on Wednesdays at 9 a.m. I know I said the first one is mandatory, but a lot of you I know there were some scheduling issues. So what I'm doing is, again, I'm recording all our classes. They are not mandatory, but come as much as you can, because that's a kind of another free time to ask me questions. And I will be recording these, but to preserve the integrity and privacy, I would maybe ask you to keep your cameras and microphones turned off during that time, and then ask me questions in the chat, because that will never show up on a recording. And then your name or picture would never show up on a recording either, even though the link I'm providing is a private link. Still, we want to preserve your privacy as well. So lab activities, like I mentioned, will come in worksheets, and they'll always be due on Sundays at midnight, as well as the quiz from the previous lab. You can print off the lab worksheet, write in your answers if you like to write, and then you can take pictures and then you can get a scanning app like Fast Scanner. It's a free app that you can kind of takes your pictures and turns them into a PDF if you want to do that. Or you can download the worksheet and type in they will always be Microsoft Word documents. So it'll be easy to edit them and type in your answers. Group work is an important component of this lab, but I know for some of you that might be impossible due to your life situation at this time. So what I have set up for you are groups. And if you go into people, again, if you joined us late, if you go into people and then click on the Bio 105 lab groups, you can join a lab group and then reach out to your classmates to set up a time to work on this virtually. You can set up a time to work on it during lab. I can put you guys in a breakout room and I can leave the Zoom running. So you guys will have time to work there, or you can come to my office hours and I can put you in a breakout room and give you time to work, or you can meet virtually on your own with Google Meets or some other form. When you do it as a group, the benefit to doing that is you get help working on the worksheet together, and then you only need to submit one, and with all your names on it, I'll give the same grade for all your group members. So those are the benefits to working in a group. You'll have like kind of helpers all the time. If group work isn't your thing or it's just not working out, just feel free to submit assignments individually as well. Let me know, because you'll want to leave that group in Canvas so that everyone doesn't get that assignment if you're working individually. So if you want to work in a group, join a group. And if not, just don't join any of those groups. And if you need to leave a group, let me know and I can help you do that as well. All righty. Quizzes, we'll be using Proctorio. You can look at the Getting Started module for how to download the Proctorio extension. I'll provide a basic calculator and a whiteboard to serve as a scratch paper in the Proctorio, but it will lock your screen and you just need a webcam and keep your face in the camera at all times. And again, quizzes are always due at midnight on Sunday. I usually open them up on the weekend. So the following week, when the first lab quiz is due, I'll usually open it up on Friday. And then the cumulative lab exam will just be on all questions from the labs up until that point. All of your quizzes and lab exam will be multiple choice. There might be a few fill in the blank questions though. Here is the final exam. December 4th through the 10th is the week of final exams. That's the end of the semester. Key to access, be present, either come to lab, watch the recordings, do your work. And then come see me in my office hours if you have any other questions. So any other questions in the chat? I'll give us about a 30-second break before I jump into the first lab. And I'll give you guys a chance to ask any questions in the chat if you have them. But I'm hoping this is pretty clear. And hopefully it'll be very flexible for your busy lifestyles. But we'll jump into the Lab One. So if you joined us late, the lab guide and the lab worksheet are kind of meant to be worked on together. And I'll show you what I mean there. So this is a look at the lab guide, and it should be in the form of a PowerPoint, but each slide will signify that page number. So for example, I'm going to go back and share the worksheet for a second. So if we look at our first scientific method and metric system worksheet, and I scroll down, there's learning outcomes on the worksheet. There's an introduction. So during this lab time, when I introduce the lab, I won't read through all the activities together, because even if we were in person, you guys would be working on this in a group or individually, kind of by yourself. They're found in both, Valerie. So if you go into modules, and they'll be found under files, but if you go into modules, the Getting Started module contains all helpful information, and then each module will correspond to a specific lab, but they'll be in both. Thanks, Vivian. So Lab One, here's our scientific method worksheet. And again, like I was just saying, we're not going to go through all the activities together, because lab is meant for you to do a little bit of kind of exploration on your own with these lab activities, but I will provide a good basis and background for it. So here we have activity 1, and if it says to see a lab guide page, that means the lab guide PowerPoint from what I just showed you, and slide 2 would be page 2. And then we usually might give you some information or some data, and then have some questions to answer. So we'll go through some of this now together, but if it says to see a lab page or a lab guide page, it will correspond to the lab guide. Do you see? So if
Professor?
Yep.
Okay, so I'm in, so I went into the files, and it says the file is part of an unpublished module and is not available yet. And also under modules, I do not, only under modules, all I see is getting started, but there is no like week 1 or it's the welcome video all the way down to the office hours Zoom link.
So there, I don't have a Lab One on your lab?
No, on mine either. It doesn't.
Yeah.
It says it's
Oh,
not
sorry guys.
published yet.
Okay, let me double check this. Okay,
Yeah.
1 second. I'm
Even
so
under
sorry,
files,
guys.
it says it's not published. Like I could see the files, but it's just not published. Like so, the first one is bio.
All right, I saw what's wrong. Now try.
Okay.
Yep, I just fixed it.
Okay, thank you so much.
So sorry, guys. Yeah, sorry about that. That was my fault. Thank you for letting me know. I'm not perfect, as you'll soon find
No
out.
worries, no worries. Thank
Yeah.
you. So I see it under modules. I reset my I refreshed it. So yeah, okay. So I have that, and then under files, it's most likely gonna be published as well. Okay, thank you.
Yes, no problem. Thanks for letting me know, guys. Oh, I'm so sorry. Yeah, well, it was my fault. I didn't publish your lab for your, yeah. All right, great. Okay, so I think we're all on the same page now. So here we have the scientific method and metric system worksheet, which is what you will complete on Sunday. And I'm just going to read through the introduction together. So the learning outcomes is we're going to understand the nature and process of science, and then apply concepts, tools, and techniques of scientific inquiry, and demonstrate the ability to apply these processes of scientific inquiry and design to the study of concepts relating to human biology. So the practice of science is dependent on a careful step-by-step process where we observe, predict, and use experiments. And this is collectively known as the scientific method. And you guys might have been over this a little bit in lecture. The scientific method consists of steps carried out in order that can be monitored and repeated. It starts with one or more observation that leads to a statement, and then that leads to a question. And then a hypothesis is formed, after which experimentation will be completed, data is collected and analyzed to either say your hypothesis is valid or not, and then conclusions can be drawn from that data collected. This process can be repeated many times to ensure that the same results are obtained. So for activity number 1, not all hypothesis testing needs to be done in a laboratory setting. Some data is based on observing, and in the following exercise, which we'll also see your lab guide in a little bit, you will be using collected snowfall data to validate the following hypothesis. And the hypothesis, again, is a statement that describes why an observation occurred. So this hypothesis is in bold: the north side of Cedar Falls received more snow than the south side of town, and the following snowfall data was collected. So it gives you the date of snow, the date of the storm, and then the average snow depth on that date between the north side of town, North Cedar Falls, and South Cedar Falls. And then it has the total at the bottom to show you kind of the total snowfall or over the course of a winter. And this hypothesis was that the north side of Cedar Falls received more snow than the south side. And then you'll have to go through the questions below. Based on the collected data, is your hypothesis validated or not? That means, was your hypothesis true that they stated? What do you guys think in the chat? The north side of Cedar Falls received more snowfall than the south side. And again, let's go ahead and open up your lab guide, which is the PowerPoint, and we'll go to slide 2 or page 2. Use your course text, lecture materials, or any other resources to review the content for the scientific method. Read that hypothesis, which was page 1, and then review the data chart to answer the questions related to that hypothesis. So again, to kind of reiterate, you can have your lab guide open at the same time you have your worksheet, and it kind of takes you through it. So again, it's very helpful to come to lab and watch the recordings, but these are set up for you to kind of work through the labs on your own. And I'm here to kind of help facilitate that. And yes, you guys are all great. So this hypothesis is false, but why? Why did you guys all say false? The north side of Cedar Falls did not receive more snow than the south side. Why do you guys say that? And you're all correct. The hypothesis is false because down here in total snowfall, even it looks like some days the north side did receive more snow. At the end of winter, they both received the same amounts of snow. So that's kind of a really easy explanation or a really easy example of this. But what we've done is we've used the scientific method. We've made an observation. We've taken data collection. So we've measured the depth of snow through the whole winter on the north side of Cedar Falls and the south side of Cedar Falls. I think that's a town in Iowa. And even though I think this person made the hypothesis that the north side maybe got more snow because on maybe more of the days it did receive more snow, but the south side had a lot of storms where it had a lot of snow as well. So our hypothesis was false after collecting data because we could see that the total snowfall was the same. Good job. So then you'll answer questions. The hypothesis was not validated, and you can say why or why not. Based on the information provided, the last column, can you explain the results of these observations? So if we look at the last column, it tells you the storm direction. So kind of coming, basically this is southwest and northeast, but if it's easier to understand, it's coming from the south or from the north, that might just be easier to think about this. So if you look kind of at the data, when the storm came from the south, which side of town got more snow? If the storm direction came from the southwest, we have one here. The storm came from the southwest here. The storm came from the southwest here. The south side of town got more snow. And that makes sense. If the bottom of my screen is south and a storm's coming from the south, it's going to dump all of its snow on the south side of town, by the time it gets to the north side of town, there's just not as much snow left. And we can see that here for the most part. So the South Cedar Falls always got more snow if the storm came from the south. And for the most part, the north side of Cedar Falls, if the storm direction was coming from the north, it would dump all of its snow on the north side of town before heading south. So based on that information, can you explain the results? You can just explain for that question, based on the direction of the storm would dump all of its snow. If it came from the south, it'll dump its snow on the south first. If the storm was coming from the north, it'll dump all of its snow on the north side of town first. So that's kind of to give you an example of the scientific method, and that's the first activity. And again, hopefully that makes sense. We're going to spend kind of the majority of the time though on the metric system, because the metric system is always a little bit confusing, but we offer you guys a lot of different resources to help with the metric system. So the metric system, we're going to read through the background together. You can read through it on your own on pages 2 to 4 of your lab worksheet. A good review tutorial for the metric system to watch before continuing with this lab, or maybe after we get done in about 20 minutes, is to watch these 2 videos. And they're very helpful. And I would say that they might even be more helpful with what I'm about to tell you, because these people who have made them have thousands of followers, and they're very good explanations for the metric system. But let's talk about what the metric system is, and we'll use your worksheet for this. So we've talked about how science demands a diligent and a disciplined approach, like investigating, forming hypothesis, collecting data, and then making observations and theories from that data. Scientists must be able to communicate with one another in a very precise fashion. So around the world, scientists need to communicate with each other so that someone who does an experiment I have my world map up, let's say someone who's doing an experiment in Europe, their data will match up with some of us who do it at UCLA, for example. So because of that, scientists observe and use the metric system, which measures length, height, width, mass, and volume with all the same units. The metric system is also called the standard system, or SI system. It's used really in all parts of the world except the United States. So in the United States, what do we use? We use inches, we use feet, we use miles per gallon, but everywhere else, everything else is kilometers, meters. So the US is kind of behind the times. We haven't quite changed that yet, but in scientific measurements, we use kind of the same measurements of material. So what we're going to practice is going between these measurements, and I'll talk to you about what we mean by that. So in the 1700s, there existed across Europe a variety of weights and measures. The English system of measurement is what we use in the States, which is even more confusing, and we're all familiar with some of these confusing. These are also called idiosyncrasies. For example, there's 12 inches in a foot, but for some reason, there are only 3 foot in a yard. More confusing, it's neither 12 nor 3 yards that make up a mile, but 1,760. And while it takes 12 inches to make a foot, it does not take 12 ounces to make a cup. It takes 8. So anyway, we get a lot of confusing in our English system of measuring things because there's so many different forms of measurement that we're using. And because of this confusion, it became necessary for scientists in Europe to meet and settle on a standard international system of weights and measures. And that's called the SI, or metric system. The basic unit of the metric system is a meter, and this is the length approximately equal to that of a yard. The meter was derived by calculating the distance equal to 1/1,000,000th of the meridional quadrant of the Earth, or 1/1,000,000th of 1/4 of the Earth's circumference. You don't necessarily need to know that, but the meter is kind of our base unit for the metric system. And some of you might have a meter stick in your homes. If you do, feel free to grab it and use it for some of these activities. If you don't, you don't need one. Due to improved techniques, we have revealed original estimates were slightly off. Anyway, regardless, we're using a meter as the basic. Each unit of the metric system then is based on combining the word meter, which is the basic for length, with a prefix to identify the unit. So for example, 1/10 of a meter is called a decimeter because 1/10 of a part is a decimeter. 1/100th is called a centimeter. So what that means is if we would have a meter stick, there are 100 centimeters in that meter stick, and there are 10 decimeters in that meter stick. 1/1000th is called a millimeter. So there's 1,000 little tiny lines in a meter stick called a millimeter, and 1/1,000,000th of a meter is called a micrometer. Likewise, if we put 10 meters together, we get a decameter. 100 meters together is a hectometer, and 1,000 meters together is a kilometer. And these and other measurements are shown in the relationship in the table shown below. After the basic unit of length was derived, the meter, we get the units of volume and mass. The cubic centimeter is the unit for volume, and that's equal to 1 milliliter. And the unit for mass is a gram. And we kind of use this 1 cubic centimeter. That's another word for saying the unit of volume for water. And that's a milliliter. And that's equal to 1 gram of water. So I know we might be kind of confused, but I'm going to keep going, and then feel free to watch those videos after we're done with class. But the beauty and elegance of the metric system are readily apparent. The same basic prefixes and relationships that are used in measuring length are also applied to volume and mass. So for instance, 1 gram, which is the basic unit for weight, can be multiplied by 10 to get a decagram, or 1,000 to get a kilogram, or if you divide by 1,000, you'll get a milligram, and so forth. And the basic unit of volume is a liter. 1,000 milliliters is a liter, and the same prefixes apply, either a decamillicentimeter. So what you're going to do is convert between these units of measurement. And if you're totally lost, it's okay, because this is usually one of the harder kind of concepts to take in. But converting with the system is easy. So for example, if you have 142 meters, the meter is our base system, and you want to know how many centimeters that is, you need to only remember that there are only 100 centimeters in a meter, and you multiply the amount of meters by 100. So 142 meters is 14,200 centimeters. If you have 8,276 milliliters and you wanted to convert it to centimeters, you simply remember that a milliliter is 1 power of 10 lower than a centimeter. So I'm going to show you kind of an easier way to how to convert these between in 1 minute, but the table below is going to show you the basic units that we'll use: meter, liter. So the meter is the measurement for length. A liter is a measurement for volume, and a gram is a measurement for weight. So this kind of gives you the base unit is shown here, and then the symbol and the prefix are shown above and below it. So we have a kilo, a hecto, a deca, and they signify 1,000 of a base unit. So 1,000 meters is in a kilometer. 100 meters is in a hectometer. 10 meters is in a decameter. Here's the base unit. We have 0.1 meters is in a decimeter. 0.01 meters is in a centimeter. 0.001 meters is in a millimeter, and so forth. And I'm going to try to show you this in a little. Let's finish this and I'll show you. Here's the metric and English conversion chart. So if you are curious, 1 inch is about 2.54 centimeters. So everything on the right side are all of the metric system units, and everything on the left side are the English conversions: surface area, volumes, and weight and masses. Okay, so then we'll use the metric system, and you'll gain more increasing understanding of this because you'll use it on a regular basis as we work through some following labs. But we're going to look at lab guide, the pages 3 and 4, to do these next procedures. The equipment and the materials list are shown here, but I believe from your lab guide, they kind of take you through everything. Okay, so this is kind of what I wanted to show you. So using the metric system is shown here, and I'm going to maybe do this to kind of help you. I'm going to give us an example here. So I'm going to insert a text box and provide a really simple example here. So let's say we have 25 meters and we want to convert that to centimeters. And the abbreviation for centimeters is a cm. And a question like this would be similar maybe to what would be on your quiz. I would give you the meters or the centimeters and you would have to convert between the two. And it's really simple. All you have to do is remember kind of the order. So this is a kilo, hecto, deca, base unit, deci, centa, milli. To convert to a smaller unit, you move the decimal point to the right. And if to convert to a larger unit, you're moving the decimal point to the left. So the decimal point, if you don't see one, is always at the end of a number. So 25 meters is actually 25.0, and the point is the decimal point. So if we're moving from meters to centimeters, we're going from a meter to a centimeter. So we're going from a larger to a smaller point of measurement. So we're going to move the decimal point to the right. And how many places we move the decimal point to the right is shown by counting the boxes over. So the base unit is right here. And if we are going to centimeters, that's 2 boxes over. So we're going to move the decimal point over 2 spots. So if we move this decimal point over 2 places, what number do we get? 2,500. Good. So this decimal point, kind of think of it, we're moving 1, 2, and if we move it over 1 point, there, it's there, that's 250. If we move the decimal point over 1 more, we just have to add another 0 as a placeholder, and we get 2,500. And so 25 meters is equal to 2,500 centimeters. Let's go through another one. I'm going to do the same example, 25 meters. And on your quiz or problems, you might just see an M, because M is the abbreviation for meters. Let's move that to kilometers, which is km. So we're going from a meter. Is a kilometer bigger or smaller than a meter? Kilometers is a lot bigger. So to convert to a larger unit, we move the decimal place to the left. And how many boxes, if we start at a meter, our base unit, and we go 1, 2, 3, that's 3 boxes over. So we have to move the decimal place 3 places to the left. So the decimal point is here, and now we have to move it to the left. So we're going to move it 1, it's between the 2 and 5. 2, it's before the 2. We have to move it 1 more, so we have to add a 0. So we're going to get 0.025 kilometers, because what we've done is we moved this decimal place 1, 2, 3. We have to add some extra zeros sometime to get 0.025 kilometers. Does that make sense so far? All right, let's do one more. Let's say we have 0.026257 millimeters. So millimeters is way over here. It's a really small unit of measurement. Let's move that, just to make this fun, to a hectometer. So same things apply. We're going to start with what they give us. So the millimeter, we're going to start in the millimeter box. How many places to the left do we have to move the decimal? Because we're going to a hectometer, which is over here. How many places to the left? We have to go 1, 2, 3, 4, 5. Good job, Yvonne, sorry. So we're moving the decimal places here, and we have to go 5 places to the left. This was a bad example because we're going to have to add a lot of zeros, aren't we? If we move this 1, 2, 3, 4, 5, what number do we get? I might even have to think about this for a little bit. Let's see, is that enough? This was a terrible example, guys. This is tricky. Did I move it 5 places over? I'm going to put a point where my decimal was, and let's see, 1, 2, 3, 4. I have to add one more 0. Terrible example there. So yes, so that was a tricky one, but does that make sense to everyone? We started at millimeters and we moved all the way to hectometers, and it makes sense that we're going to get a really tiny number because we're starting with a millimeter and we want to know how many of those millimeters is in a hectometer, which is huge. So it makes sense we'll get a really small number. So what we've done is we moved the decimal place 5 over. So I'm just going to put my decimal where it was, and then I had to add a lot of zeros. I had to add 1, 2, 3, 4, 5. So I had to add a lot of zeros. Let's do one more and then I'll be done. And we can apply this to any base unit. So now let's say we have 45. I need to think about what I'm doing here. Okay, so a kg is a kilogram. And how many kilograms are in a, let's do a centigram. So we're starting at kilograms, which is over here. Kilograms is on this side, and we're moving to a smaller unit. So we're going to move the decimal to the right. How many places do we need to move the decimal over? 1, 2, 3, 4, 5 to get to a centigram. Good. So we're going to take our decimal here and we're going to move it 1, 2, 3, 4, 5. So we're going to get 450 centigrams. All right. We're going to keep moving on. If you guys are still kind of confused with that, watch these tutorial videos because they'll kind of describe the similar way of doing that. But the easiest way to do this is just to take with what they give you. You have to learn the prefixes and then kind of remember these box orders. And there's kind of an acronym that helps you remember this. King Henry drank, I don't know, something. King Henry died drinking chocolate milk. So King for K, Henry hecto, died deca. The base unit is nothing, put a space mark there. So King Henry died and then drinking chocolate milk, deca centa milla. So if you can remember that, that'll help you remember the order of those letters. Oh, thanks, Valerie. You guys are nice. So just keep that in mind. And then that's the easiest way to do this. Take with what you start from and then move the centimeter either to the right or the left based on this chart. I'm not going to go through all of this with you. The fraction method, shortcut method, here are even more reviews on how to do metric system conversions. But the following kind of questions take you through the meter stick. And they give you activities for how to use a meter stick. They'll ask you questions about how many things make up parts of a meter stick. I'm going to move over some of this rather not quickly, but I'm going to let you guys work through some of this on your own, if that's okay. If you have questions with it, however, come see me in my office hours, or please, please, please always send me an email. This kind of tells you, but 1 decimeter is 1/10 of the meter. So what that means is that these are the decimeters. A meter is divided into 10 kind of equal parts, and that's a decimeter. A meter is divided into 100 equal parts called a centimeter, and 1,000 equal parts called millimeters. And you can see those shown here. Those are the centimeters, and then here are the millimeters, the smallest markings. So that's activity 2, and those questions based on page 5 of your lab worksheet. Here's another tutorial on a meter stick if you need that. So I cannot give Melanie Fierro credit enough. She's the one who made these labs for you, and I think they're very easy to do. If you're a self-starter, a self-worker, you could probably do these without me. But again, I'm here to help you. Come to lab, watch the recordings. All right. Activity 2, another one I've kind of the furthering on is talking about the procedures for measuring mass. And let me just go back to your worksheet here. So procedures for measuring length, do these the best you can. Have both the lab guide and the worksheet open at both times, and it'll take you through and work it together. And I'm going to kind of skip ahead a little bit. In inch, you might have to go back to see or how many that we give you, how many inches are in a centimeter, and then you'll have to convert centimeter to millimeters for this question. And again, I don't mean to skip over this, but in a live, if we were in person, what I would do is I would kind of do the same thing. I would let you guys work on your own with this. So that's why I'm not going over every single question together. You will have to measure some things, but you can see the lab guide pages that'll give you those measurements in your lab guide. Then measuring mass is shown here. In the English system, we use pounds. Everywhere else, we measure things in kilograms. So I haven't told this to you yet, but I'm actually teaching you guys from Quito, Ecuador. And whenever I take my babies to the doctor, I have 3 kids, they give me their weight in kilograms. And I still can't get used to that. So I always say, doctor, can you please tell me in pounds? So even I have to do some conversions. So as we go through this, you guys are going to be in lab. We're going to pretend that we have a digital scale and measuring the mass of a quarter, but the lab guide will take you through this. Before you begin measuring anything in a lab setting, you need to tare the plastic weigh dish. And what that means is that if we have a measurement, a weigh scale, we're going to put a plastic weigh dish on the scale to measure what we put in it. Well, we don't want to measure the weight of the plastic dish, so we tare the scale, which means you set the plastic dish on the scale and you tare it or set it to 0, or you can take the measurement of that plastic dish, which is the tare mass. And the tare mass you can record from the lab guide. So they give you the mass of the weigh dish, which is 2.14 grams. So what that means is you want to take the tare mass, you want to remember what the weight of that dish is, because we want to know the weight of a quarter. We don't want to know the weight of a quarter plus the plastic dish. So the tare mass is just the weight of the dish that you're going to take. So you'll take that down and it's 2.14 grams. And then you'll work your way through some of these. A mass of a tare, it gives you the mass of a quarter, or it gives you the mass of the tare and the mass of the quarter, which is 7.81. And then it asks you for the measurement of the quarter itself. So you kind of have to go back to your worksheet. The total mass, you'll add your tare plus your quarter is 7.81. So it even highlights for when you need to look at the lab guide. You take the tare mass, which is from above, which is what you got, about 2 grams. And then you'll take the mass of the quarter by just subtracting them. And hopefully that makes sense. Your identification card will give you the tare mass of that and the weight of a normal identification card. And then we'll do volume. So in lab, we would use different graduated cylinders and beakers to measure volume. So we're kind of just practicing basic lab procedures. To measure volume, we record the measurement of volume by looking at the meniscus. And the meniscus is kind of a dip in the level of a liquid in a graduated cylinder or a beaker. So here we have a 10 milliliter graduated cylinder, and it's showing you, you can see how a meniscus is the meniscus is the bottom part of the curve. So you always measure the volume in a container where the bottom of the meniscus and what line that hits. So this meniscus is right at the 10 milliliter mark. So this graduated cylinder would be 10 milliliters. Here are differences, beakers and graduated cylinders. Here's a 100 milliliter graduated cylinder. That's a 10 milliliter graduated cylinder. And here's a beaker. I think it's a 40 milliliter beaker. And you always measure kind of the level of water based on where the meniscus level is. And the meniscus is the curve part, but it'll be the bottom of the curve where you want to measure that line. So let's take us through back here. It takes you through what a meniscus is, how to measure it. It asks you to draw 3 common pieces of laboratory glassware. And you can use that picture that I just showed you from the lab guide to draw those 3 kind of very basic pieces of laboratory glassware. You can also use these pictures to have a more look. That's a 50 milliliter beaker. So you can practice drawing that. You can add the lines in with the measurement numbers. You could practice drawing the 10 milliliter graduated cylinder and the 100 milliliter graduated cylinder. Then we'll use the metric system to kind of measure different weights of water. So similarly, you'll measure the mass of an empty cup. You'll have to record that. You're going to, or this person will pour 10 milliliters of water into the cup and then measure the weight of the cup plus the 10 milliliters of water. And you guessed it, you'll probably have to subtract the two to find kind of the weight of the water itself. And you'll do that, you'll write down the weight of the cup, the volume in the cup, which will always, I think, be 10 milliliters. And then you'll have the weight of the cup plus water, then the weight of the water and the expected water. So pretty soon I'm going to let you guys work on some of this on your own. I think you'll continue to use the lab guide to take you through that. You'll measure temperature. So we'll talk about temperature. To measure temperature, we sometimes do converting between Fahrenheit and Celsius. And to convert between Fahrenheit and Celsius, there's formulas that we use. So for example, if it is 37 degrees Celsius outside, we take 37 and we plug it into where the C is. We take 37 times 1.8 first, because we always do what is in parentheses first. And then we add in 32 to get the Fahrenheit temperature. And if we need to convert Fahrenheit to Celsius, let's say it's 77 degrees Fahrenheit outside, we put 77 into our formula, 77 minus 32, because we always do what's in parentheses first. We divide by 1.8 to get Celsius. There are some experiments using thermometers, and then you can see the lab guide, which will take you through those experiments with the thermometers. I think what it'll do is it'll just show you so you can go through the slides. And does this lab guide, it ended a little short. Let me make sure it has everything you need. See lab guide, page 34. I'm just going to make sure. Oh, here we go. So it'll give you the temperatures that you'll record to use to fill in your worksheet. Additional questions are kind of doing some conversion units between milliliters and grams. We're going to kind of use the last couple questions. So you'll do some conversions either between temperature, kilograms, milligrams. So you're going to do some conversions of temperature and of the metric system. I'm going to finish talking a little bit about converting water to grams. So what we didn't kind of go over yet is that the special attributes of water, and let me go ahead and download this because this will just be easier for me to download quick. And I'm going to pull up the special attributes of water, and I'm going to reshare to make sure you guys can see what I'm looking at. Okay, so I'm going to go to the special attributes of water. And if you read through the whole worksheet, it'll talk about this. But your first question here at the end talks about how many milliliters of water are equivalent to 1,000 grams. And you'll notice here that we're using two separate base units. We have a milliliter and we have a gram. And we normally can't convert between milliliters and grams, or a liter and gram. Everything has to be a gram, converting grams, meters, or liters. But here we have a milliliter, which is ml. And we have a gram, which is G. And the only thing that you need to remember here, or keep in mind, is that 1 milliliter of water is always equal to 1 gram of water. And this always has to do with water. So if we have, for example, this question asks how many milliliters of water are equal in 1,000 grams. What do you guys think? It's always just a 1-to-1 ratio. So 1 milliliter of water is equal to 1 gram of water. So how many milliliters of water would be equal to 1,000 grams of water?
1,000?
1,000, yes. So the answer to this first question is just 1,000 milliliters of water are equal to 1,000 grams of water. And that's because converting, so normally we can't go between base units. What I mean is that the base units are meters, M, grams, G, and liters, L. And with those base units, we can convert in our King Henry died drinking chocolate milk chart. But normally we can never convert between the base units, like a gram to a liter or a meter to a liter, except in the case of water. Water has extremely special properties. So distilled water, if we were to weigh out 1 gram of water, that would be exactly equivalent to 1 milliliter, the volume of water. So this is a special situation of water where there's a 1-to-1 ratio, 1 milliliter of water equals 1 gram of water. And this is what you just have to keep in mind. And I think, let's see if there's any other questions relating this water. So let's go through number 7. And then I'll let you guys go here. And I'll post this recording if you need to look back at it. So number 7 asks to determine the mass of 10 liters of water in grams. So let's go back up. We remember that 1 milliliter of water is equal to 1 gram of water. To use our 1-to-1 conversion chart, what do they give us? They give us 10 liters of water. And we need to convert that to milliliters first, because once we convert it to milliliters, then we know that that many milliliters will just be that many grams, because that's what we want to get. They're asking us for the grams. So to convert 10 liters to milliliters, let's go back to our King Henry died drinking chocolate milk chart. So I'm going to take us back up to this. You're going to just love this unit. So we're going to try to convert, again, liters to milliliters. And we have 10 liters of water. So we have 10 liters of water. So we're starting at the base unit. We're already at 10. So I'm going to erase this. We have 10 liters and we're turning that into how many milliliters. So we're give us 10. We're at the base unit is a liter and we're going to milliliter. How many places do we need to move the decimal place to the right? 1, 2, 3. The decimal place is there. And if we move it 3 places over, we're just kind of adding on 3 zeros. So 10 liters of water is equal to 10,000 milliliters. Good. So let's go back to your worksheet. 10 liters of water. I'm going to paste what we just figured out. 10 liters of water is equal to 10,000 milliliters of water. So now 10,000 milliliters of water. How many grams of water is that? What do you guys think? $10,000 milliliters of water is how many grams of water? Good, it's just 10,000 because if we look up here, our special property of water says that 1 milliliter of water is equal to 1 gram. It's a 1-to-1 ratio. So we first just had to change liters into milliliters to use the special rule of water. And then since we know that 1 milliliter is equal to 1 gram, 10,000 milliliters will be equal to 10,000 because it'll always be kind of equal. All right. So with that, I'm going to let you guys work through. I think you can work through the rest of this and fill it out using the guide as you work through this. And again, we won't go through all of it together because if we were in lab together, I would at this point let you guys work on your own. So I'm going to go ahead and stop the recording now.